Hello everyone. With the advent of LLMs, there have been lots of use cases which have opened up recently, and at times we tend to do over engineering. So I thought, let me make this video inspired from one little coder of the app levels for LLM. So what does it mean? LLM can be used to build different apps, but all fall under these 5 categories. And the hierarchy goes as follows. The first one, which is at the bottom, would be the general QA, and then the next one would be Chatbot, and then RAG, then Agent, then LLM OS. Okay, this is the hierarchy from bottom to top, where the least complex and least powerful in the hierarchy would be general QA. The most powerful and the most complex one would be the LLM OS. All right. So in detail in this video, I'm gonna show you about the characteristics of each of these levels and what can be achieved out of these levels and when you should use which level of application to your application actually. Alright, so that's what we are gonna see in this video, and like I said, these are the 5 levels of LLM apps which is existing in the current world. Probably the hierarchy might increase because even LLM OS is under developing stage currently. So there might be some other things which could be included in the hierarchy lately. For example, AGI, which is not coming anytime soon in my opinion. But if it comes, that could be the next step in the hierarchy. But at the rest, these are the things which are available right now. We'll start with the general QA. So what is a general QA? It is about answering a question based on self-knowledge or given a context. So what do I mean by that? Let's see about that now. Okay, you see, if I ask a question stating that what is the planet we live in, okay, if I ask this question, the LLM, whichever LLM is there, it's gonna say easily that it is gonna be Earth, right? This is no context question answering, okay? No context QA. That is what is the first one. Or else even there is another thing which is known as context question answering, which is, for example, I'll say, okay, there is a paragraph about what is IPL, and if I ask what is the full form of IPL, I'm assuming that the model doesn't know, okay? What is the full form of IPL? Now it will answer the question actually that it is Indian Premier League, something like that. Okay, so that is context. There are some other examples as well. For example, reasoning. Reasoning is also a type of QA. Okay, reasoning, context question answering. Usually with reasoning, you will need a context because, for example, if I say I have 2 apples, my father gave me 2, how many do I have? If I ask this question, it will say, okay, 2 plus 2 equal to 4. It is reasoning it, right? Okay, gave, which means I need to add. Okay, this reasoning is happening, right? So these are the types of QA at the top. But if you see, any traditional NLP task can be seen as a QA task. For example, if I say, I like YouTube, okay? If I say this and I ask, what is the sentiment expressed? If I ask this question, right, of what is the sentiment expressed, it is going to say positive, okay? And we can also force it to generate in however way we want. For example, I have 6 categories here, okay? I have 6 categories here. Find the sentence of which category it falls under and say only the category. If I say that, it is going to work as text classification. Similarly, we can do NER, we can do summarization, okay? There are lots of tasks which all are possible to do with the help of QA because the question will be our instruction, alright? So any traditional NLP task can be seen as a general QA task, okay? So here the in context memory is not there, the external knowledge is not provided, tools, nope, peripheral tools, no. These are some of the characteristics in which we are going to base these hierarchy, and like I said, this is the least powerful, but yet it would have seen, right? If you have any task for you at a minimum level, then you can do it with general QA. Okay, all you need to do is provide your prompt to a LLM and then you'll get your answer. Okay, but it doesn't have any of these. Okay, now what if you want to remember some of the context you had, like a conversation? That is when we'll move on to the next level, which is chatbot. Okay, chatbot is just an extended QA. Okay, it's just an extended QA which will have memory of sequence of conversation. But like I said, anything is applicable to chatbot as well. For example, if I'm saying summarization, on top of that I can ask a QA based on the summarized passage. If you see ChatGPT, the original ChatGPT 3.5 was just a chatbot. Now it is not a chatbot. I'll say what it is. The original ChatGPT 3.5 is a chatbot. Okay, because you can ask it to summarize, you can ask it to answer your question, whatever you have as a task, you can do it with the help of ChatGPT, and also it remembers your conversation, and that remembrance is nothing but in context memory. Okay, so in context memory is there, but external knowledge is not there, tools is not available, and peripheral tools is also not available, and that's why we have added answer to the prompt. This is not like an RNN architecture where it will retain its memory state. Okay, so that is the difference between chatbot and QA. A QA where it will require you to remember the conversation, that will become a chatbot. Okay, so when you have a requirement for remembrance of memory, then alone you need to go for chatbot or just go for QA itself. Okay, now it is going to be a step up. Okay, what if your LLM has a context which it doesn't even know? You can't provide a context explicitly, but you have a data source. Okay, for example, if I say this is a document, okay, and each line is a page, okay, and each line inside line there are some group of paragraphs, okay, and this is how the document is right now. If I ask a question from here, right, the context length is going to be about 10,000 or 20,000. So the model can't answer. This is not going to be the context. This can't be the context. Okay. So for context, what we are going to do is we are going to do a retrieval process. Okay. So what happens in this retrieval process, right? So now what I'm going to do is I'm going to create a document just of 3 pages. Okay. And here the pink page is my answer. Okay. So given a question, so whatever question I have of what is some blank, okay, and the most relevant one would be this one, this page, and then the second most would be this, and third most would be this. So what I will do is consider that those are paragraphs. Okay, I'll just provide the second paragraph as context along with my question. Again, if you see, this is QA, but the context finding process is automated. Like I said, everything is built up from QA. Okay, and here RAG is just an extension where you find your context automatically. Okay, so that is RAG, Retrieval Augmented Generation. You will retrieve a context which will augment or help in your answering process. So that's why it is Retrieval Augmented Generation. And here, like I said, it is a chatbot or QA system with an external data source for knowledge, because you can still apply this for chatbot where you can have a sequence of conversation based on your RAG system as well. Okay, so for a single QA system or a chatbot, if you add an external source of knowledge to find the context for a given question, it is going to be a QA system or a chatbot which is done with the help of RAG. RAG is just an extension. Okay, here we have an architecture. You have your database or documents, your API, whatever type of data you have, you will index those. Okay, where you will compute your embeddings. Okay, so this is your vector store, and what happens is if you have a question where you know that you can't provide a context and you know that the model wouldn't have a knowledge of that, then only you are going to use this RAG. Okay, and it will try to find the answer based on this vector store. Okay, and then what it will do is it will go to the LLM where the prompt, your query, your relevant data all are provided to the LLM and it will provide the response to the user. Okay, when you need to use RAG, only when the model doesn't have a knowledge for the question by itself, or you can't provide the knowledge by yourself explicitly. Okay, if any of these two are possible, you should look onto a normal chatbot or QA system, because this is more complex than a chatbot or a QA system, and it is also more time consuming. Okay, so RAG when can be used? When you want to chat with a PDF or a doc, any type of document, or you want to chat with websites, your databases, anything in which there is a huge context and you can't find which context you want. Okay, that is when you're going to use RAG. So for this, in context memory, like I said, if it is a chatbot, you will have, and if it is not a chatbot, you won't have. So it is going to be yes or no based on your system you're going to choose. And external knowledge, it is going to be there for sure. That is what is going to characterize this as RAG, but tools won't be there and peripheral tools won't be there. But probably at times RAG might have some tools. That is when we call it a chain. Okay, a chain where if you want, you can load your websites with the help of tools like for example Beautiful Soup, and then it will perform this RAG architecture. Okay, so at times this is possible, but at time that time it is known as chain, and chain is not very useful because that is something you explicitly define that okay, this is the procedure, and you need to solve the use case based on this chain. Okay, regardless of if the chain is correct or not. And that is why there is this architecture which has come recently known as agent, where it is an upgradation over chain, not RAG. Okay, this is an upgradation over chain where we'll say that okay, your tools are here. Okay, your web selection tool, your document loading tool, whatever tool. For example, this is a PDF loader tool, this is a CSV loader tool, this is a database related tool, this is a web-based loader tool. Based on the type of input, it can choose whatever tool it wants by itself, and then it will augment its knowledge and then answer the question. This is a simple explanation of why this is an upgradation over the chain, because it can do the task autonomously, where the chain has human intervention because human is what is creating that chain. Okay, but in case of agent, you will just provide the tools in an environment where the agent can use that. Okay, this environment is nothing but your agent executed environment. Okay, so that is about an introduction to agent. Okay, so given an input, the agent, which is nothing but your LLM, which has all the tools in its toolkit, it will find okay, which tool should I use now, and based on the tool it will use the tool with the help of a concept known as function calling. And if you want to know in detail about function calling, I have made a separate video on function calling, please check that. And in nutshell, what is function calling is each tool 1, tool 2, and so on and so forth will be just Python functions. Okay, and this function calling is nothing but it will just provide this function and we'll parse that and do a function call based on the parameters it provides here. Okay, so that is what is function calling here. For example, if I want to load a document, it will be for example PDF of file path. Okay, so it will call PDF of some name dot PDF. Okay, so it will load the PDF documents by itself. We are not saying. Okay, same goes for any document. So that is how agents work. So this is a simple use case. You can do a lot of things with the help of agents, and lot of videos are coming up in your way where I do a lot of complex tasks with the help of agent, and already I have done some things like stock trading analysis and lots of other things. Okay, when you know that these are the things which are required to do a task autonomously, that is when you will go to agent. Okay, a task which can be automated without any human intervention, and only when this is required. Okay, when we require to do an automation, and you know that okay, when I provide these specific tools, I need not intervene in there, then only you're going to go for agents. Okay, so here you'll have it in context memory, yes or no based on your task, external tool knowledge, yes or no based on your task. Now you might wonder, okay, now I was emphasizing on tools, so here I didn't provide any tool. Yes or no is what I have provided. Any LLM which can do a given task autonomously is an agent. That is what is the definition for agent. And people are confusing over internet if you wanna check. But this is the exact definition. If you see, if I give summarization as a task, right, it doesn't need any of these. In context memory, external knowledge, tools, nothing is needed. And it is also an LLM, it is also an agent. So that is why I say everything is built up from QA. QA is also an agent, a question answering agent, right? So here, but there is an opportunity that you can do complex tasks by just adding tools to it. Okay, but peripheral tools are not still provided. Now you might be confused, okay, he's just repeating the same of again and again, and here is the difference. If you are doing a normal QA, and let's see about the difference right now. Okay, if you are doing a normal QA or a chatbot, this is gonna be your thing. You'll give your prompt, you'll give it to your LLM, and it will give your answer. And if it is a chatbot, you will append your answers and the prompt to your prompt again. That is gonna be chatbot. What if it is RAG? You will provide the prompt, which is your question, and what it will do is you will try to find the relevant context from here with the help of retrieval process, and your context and prompt are together sent to your LLM and the answer is obtained. Like I said, again, if it is a chatbot system, you will add those to the context again. Okay, but if it is a agent, what you will do is you will provide your prompt. All right, it has access to reasoning by itself. It has access to the memory, which is nothing but a vector store for RAG process. Okay, it has some other tools as well, for example executing Python program or whatever it is. So what it will do is it will try to find, okay, which process I need to do, and then it will do the action and it will say the answer as well. Okay, everything is done by the agent itself. So this is how is the difference between agent, RAG and the previous QA or chatbot system. Okay, so this is the current scenario in the world. Okay, this is the most complex architecture which is commonly used right now. Most complex but commonly used. So for this you have packages like QA which you can use, alright, or Autogen as well, but Langchain is also good if you want to create by itself. There is a step up which is done right now, which is LLM OS, okay, which is currently under development, alright, where LLM will control your OS. Here is an architecture from Andre Karpat, okay, he is the one who first defined this, where you will have your LLM loaded into your CPU, which is occupying your RAM as well, where it will have access to your file system, it will have access to some tools, whatever tools is required, for example calculator, Python interpreter, shell, or your Chrome, your browsers from here. Because it has connection over net, it can do some browsing as well. Probably if required, it can access some other LLMs. There is some peripheral devices as well which it can context with, for example video, audio, for your mic, your camera. It literally has access to anything in your computer or your laptop, whatever it is. Okay, if you see, in a way, everything is going to provide a data that is going to be a context. Yes, this is going to be your tool. Okay, your context is obtained from either video or audio or even normal text. Okay, and that is provided to your LLM, and these are all tools. Okay, these are all tools, and your LLM is going to take an appropriate action and answer your question. If you see, this is just an extension of your agent, but there are multiple agents in here. That is one, multiple agents, and two, it has all the tools to control the OS. Okay, that is when it becomes LLM OS. So the only difference between agent and LLM OS is that this agent is a general backbone kind of an architecture which can be used for any task, and this LLM OS is an architecture by itself which is used to automate your whole computer. Okay, so for this it requires all of these things. There is no option of no and all. You will need in context memory, you will need an external knowledge, you will need tool, and you will also need peripheral tools. It will require all of these. So this is the most powerful and the most complex, because it is gonna require a lot of things for you to do. Imagine you need to create hundreds of tools. Okay, your file system is huge, so you need to compute embeddings for those file system, so that if you want it to open a file or read a file or write a file, it will be able to do that by itself. Or if you want to chat with video or audio, it is going to be a huge context. So there are lots of complexity in this. Okay, right now people are working towards this, and recently you could have seen the Copilot, which can see what you're doing, is coming up from Microsoft. That could be a step towards this LLM OS, and already I've made a video of LLM OS with some 3 sample tools, but it is not gonna be enough. All right, you're gonna need a lot of tools, but that is a sample of what you can do with the current LLMs to become an LLM OS. Okay, but if you see as a common thing, right, everything is gonna be a QA or a chatbot. That is the base architecture. All right, and the way you're working is, if you want to automate, you are going to add some tools. If you don't have a knowledge, you're going to augment your knowledge, but everything is just an extension of QA. Okay, so that is why it is very important for you to have an understanding of how QA or chatbot works and how you can extend those for your task. Now I'll say when you need to use what. QA, when you have a context by yourself explicitly, or you have just normal reasoning, or you have general QA which does not require which has the knowledge by the model itself. Okay, for which if you want to answer the question, the model has the knowledge to answer the question. That is when you'll use the QA. Okay, chatbot is just when you want to remember the sequence of conversation. If there is a sequence of conversation, then you will need chatbot. Okay, RAG, if you want to find the context. Okay, that is when you will go for RAG. If you want to automate your process, knowing that you have tools and it is not solvable by the previous task, by previous levels. Okay, because like I said, even summarization is an agent, and if you're gonna use a crew AI to build an agent, it doesn't make any sense. Okay, you can just give a prompt and it is gonna be a summarization agent. Okay, if you need some automation where you have all the tools and it is not solvable by any of the previous level, then is when you will go for agent. An LLM OS to completely control and completely automate your life probably in the future, but right now completely automate your computer or OS. Okay, so these are the levels, and these are the things you need to do when you have a specific use case. All right, why is it this? Because I have seen people doing over engineering. Okay, for example, for summarization, I have seen people using agents. Okay, why do you need summarization agents when you can just use a simple prompt? Okay, they are using complex architecture for no reason at all, and we don't know what is happening beyond the agent architecture. Whoever creates it, for example, Crew AI, AutoGen, or any other framework, doesn't matter. But they are all using F strings again, by using Jinja template. That is another thing. But again, see, we don't know what is happening behind. Okay, so we should not do over engineering when it is not required. All right. So that is why I made this video of what is there in different levels and when you can use which level. All right, and it will also say what state we are in the LLM world right now. Okay. So again, thanks to one little coder. He's a good YouTuber. You can also check his channel, One Little Coder. He posts videos daily, unlike me. Alright guys, I hope you all like this video. If you all like this video, please hit the like button, share it with your friends who might do over engineering, alright, or who might need to know what is happening in the LLM world right now. So yeah guys, I hope you all like this video. Please let me know in the comment section your thoughts of this video or what you want next. If you haven't subscribed to the channel, please subscribe to the channel. I'll see you on the next video guys. Until then, cheers.